Now, previous lecture we calculated the first order energy correction, and now we should calculate the first order vector correction. In previous lecture, we obtained the relationship between from the Hamiltonian equation, and for example, n equal 3 state, and E10 minus E30, and here C31 first it is a vector component, and E20 minus E30, C321, and also third one is that 0, because E30 minus E30, and E40 minus E30, and the C341, it is one vector component, and then the Hamiltonian component minus H13 prime minus H23 prime. Here we only talk about the n equal 3 state as a for example case, and here E31 minus H33 prime and minus H43 prime, and so on, like this. So, and we should remind that this 0 is important. Here we know, and the first order state vector in this case, for the in general, we can say that EM0 minus E30 C3M state, then minus HM3 prime. Here M is not 3. From here, in general, 1, 2, 3, 4, and 1, 2, 4, it is M, it is not 3, and also C3M, and minus HM3 state, M3 prime. So then we can know that C3M first correction is that HM3 prime over E30 minus EM0. Here M is not 3 state. Actually, we don't know that here because M is not 3, and here M C331 we don't know, and because we know that the energy eigenstate can be expanded like zeroth order, and first order, and second order, and energy eigenstate can be expanded like also zeroth order to the first order to the second order, like this. So when you assume that there is n equal 3 state, then the vector of the 3 in the first order can be written like that: C31 first order, C32 first order, C33 first order, like this. So, and we should think about that the first order of lambda. Here, let parameter equal to 1. Then for 3 state can be write down as the ground state plus first excited state, first perturbed state, not excited is the perturbed state. Then ground state is solvable from the obtained from the solvable Hamiltonian, but the first order case we do not know, but it also can be expanded like a basis as a basis for M0. M0 and the C3M first one, then the summation from M equal to 1 to N state. Then here in 30 plus, because see M equal 3, because in this case M is not 3, so and we should separate C331 state 30 plus summation summation M from the 1 to N state. Here M is not 3, and the C3M first and the M0. Actually, we do not know this coefficient, but don't worry about that. And also in this case, 1 plus C33 first coefficient 30 plus summation M from 1 to N. Here M is not equal to 3, and C3M first M0. Here we use the normalization condition. Normalization from the normalization 3 by 6, 3. Then in this case, and a complex conjugate, and 1 plus C33 first order complex conjugate, and 30 plus, let's use the different indices, and the K from the 1 to N. Here K is not equal to 3, and C3K first order complex conjugate, and K 0th order like this, and also multiply here, multiply this. Then multiply this term and this term. Then 1 plus C331 complex conjugate, and 1 plus C331, and plus, because M is not equal to 3, and this term multiply this one equal to 0, and also this one multiply this one also equal to 0, because M and K are not equal to 3. So only two multiplication for the two summation for the K and M. Here K and M, both of them do not equal to 3, and also here C3K first complex conjugate, C3M first, and then the Km should be normalized, so chronic delta Km. So when you calculate, and 1 plus C33 first, and C33 first complex conjugate plus C33 first square, and plus, because only K should be equal to M, so only M from 1 to N. Here M is not equal to 3, and also C3M first square. Because we only consider for the first order correction, and it is a second order. It is order of second order, so let's ignore. Then also it should be normalized to 1. It means that in the C331 and the minus equal to minus C331 star, equal to 0. Then it means that, and here C331 is real, not imaginary. All right. It means that there is no component of zeroth order eigenstate in the first order energy correction state. And in other words, and here when you draw vector representation, at first zeroth order eigenstate can be perturbed by the and some m state, first order energy eigenvector, then the total eigenvector should be n. And also, in other words, here C33 first is real value. It is a real value also, and also in other words, there is no component of the zeroth order eigenstate of 30 state in first order eigenstate correction. So here the first order eigenstate correction, here it is first order eigenstate correction, and also in the first order eigenstate correction, and if it is C is a real case, and C33 equal to 0, because it is a real value. So, and also it means that it should be 0. Okay. So it means that there is no component of the zeroth order contribution, because it is a 0. So there is no 30 state correction in the perturbed eigenstate. So it means that it is orthogonal with zeroth order to the first order. Zeroth order and first order is orthogonal. So here in general case, and we can say that perturbed state and first order perturbed state is orthogonal to original eigenstate. So because there is no component of zeroth order, and we can say that in this case, and for example m equal 3 case, the first order correction can be write down as like this, and because we should remember that the CM1 state, CM first order correction is like this. In the C33 state, C331 first order equal to 0. So, and we can write down the part of the energy eigenstate H13 prime over E30 minus E10 and E30 minus E20 H23 prime, and also third term is 0, and the fourth term is that E30 minus E40 H43 prime, like this. So in general case for state 3 is that 0th order plus perturbed state, and then the energy eigenstate is like this. Is like this, and also this term is that the 1. In here we should remind that it is a 0. So in general case, C and M, it is coefficient of the each state. H and M prime over En0 minus Em0. Here N is not equal to M, and also C and N first order equal to 0, and we should remind this one. Therefore, when we write down this, and here in general case, in the first order energy eigenstate, summation M is not to N, M0 H prime N0 En0 minus Em0 in M0 state. So it is very important to it needs to memorize. Here it is a first order energy eigenstate. Is first order energy eigenstate can be expanded like unperturbed energy eigenstate, and also this coefficient is like this, and it is matrix element of the perturbed Hamiltonian, and over En0 minus Em0. Okay, so in general case, and we know that in the first order equation is Hamiltonian equation is the H0 minus En0 N1 equal to En1 minus H prime and N0. Then when you apply N0 here, H0 minus En0 N1, then N0 En1 minus H prime N0. Then because of this, and also when we apply this one, and also it is N0 and En0 from the eigenvalue equation, so then it is orthogonality, and it is in the left hand side is 0. Then first one is that En1 N0 N0 minus N0 H prime n0. So the first order energy is written like this: n0 Hamiltonian prime n0. So, and in general, then the first order perturbation correction is that energy eigen state and energy eigenvalue is that En0 plus N0H prime N0, and the energy eigenstate is that N0 plus summation M is not equal to N M0 H prime N0 En0 minus Em0 and M0. And we should remind, and it is very important. It is very important here. So it is a general formulation of the first order perturbation theory. And let's make an example. Let's have an example. And if we think that the potential well let's think that the infinite potential well like this. It is infinite scale well, and the well H is L. Then we know that in this case energy eigenstate is that pi square h bar square over 2m L square n square, and also energy eigenstate, in other words eigenfunction, is that sine n pi over L x. Then here it is ground state. We already calculated exactly. Then if the potential has a small perturbation like this, the perturbation is that it is infinite, and in half it is infinite, but it is a V0 at x L half and L like this. This kind of perturbation in some cases. So in this, we do not know that the exact Hamiltonian, but here in generally first order energy is that N0 H prime N0. Then in other words, in this case from the integration, and from minus infinity to infinity, phi n ground state star potential in the phi n 0 x dx, it is anyway, and it is potential V0. Then it can be write down as the from the 0 to L half phi n 0 star, then the potential is 0 in this case, phi n 0 x dx, and actually it is a 0. Then from the L half to L phi n 0 star, it is potentially is V0 phi n 0 dx. And then is that V0 is constant, L half to L, in the phi n 0 x square dx. Then from the normalization, and we can know that it is 1/2 V0, because let's think that phi n is like this, phi n 0 like this, so sine square, then it is 2 half 2 over L, and also 1 half one minus cosine 2 pi nx dx. Then it is that from it is this term is 0, so it is 1 over L multiply L half, so it is 1 half. Then so we should remind that, and we should know that the Hamiltonian first order perturbation energy and energy and energy eigenstate should be memorized.